On the morning of January 6, 2025, at 11:15 a.m., a man named David Morrow was sitting on the balcony of his apartment, enjoying the views of the Pacific Ocean, just like any other day. It was a normal day until he noticed flames sparking in the hills of Pacific Palisades, about 5 miles away from his apartment. Within just an hour, the fire grew so rapidly that smoke completely engulfed the hills. According to satellite views, the fire was first reported in the Pacific Palisades hills. However, within a few hours, it had spread to Eden Crest, Kenneth Getty, Skirball, and the San Fernando areas. At the time of the fire, winds were blowing at a speed of 100 kilometers per hour from inland toward the ocean. Now, the question arises: if the fire started in Pacific Palisades, which is right by the ocean, how did it spread 30 to 40 kilometers inland in the opposite direction of the wind? This wildfire has devastated a total of 38,000 acres, 150 square kilometers, destroyed more than 12,000 buildings and homes, and displaced over 180,000 people. This is the most destructive wildfire in Los Angeles history and has yet to be fully extinguished. Efforts to extinguish the fire seem to be failing. Water bombers are dropping 45,000 liters of water at a time, which feels like a mere drop in the ocean compared to the massive blaze. Special chemicals are also being dispersed with water bombers, but nature seems unstoppable. California, which already suffers from a water shortage, often finds its fire hydrants empty. The fire spread across 7 different areas, dividing the firefighters and their equipment. To make matters worse, the winds blowing at 70 to 100 kilometers per hour further fueled the flames, intensifying the fire. Before understanding the real cause behind the spread of the Los Angeles wildfire, let's take a look at the history of wildfires in California. Over the past 25 years, California has been a hotspot for wildfires. For example, in 2003, the Cedar Fire in San Diego County burned 273,000 acres between October 25 and November 4. In 2017, the Tubbs Fire burned 36,000 acres in October. In the same year, the Thomas Fire consumed 280,000 acres, starting in December and ending in January. On November 8, 2018, the Camp Fire burned 500,000 acres and ended on November 25 after 17 days. Similarly, in 2020, the Glass Fire burned 67,000 acres, beginning in September and lasting until October. If we analyze the dates of these wildfires, a common pattern emerges. They all occurred during the winter months. The ongoing Los Angeles wildfire also erupted during peak winter. So, why have most of California's wildfires historically occurred in winter? The answer lies in a phenomenon called the Santa Ana winds. The Santa Ana winds are warm and dry winds that occur primarily in Southern California and Baja California during autumn and winter. To understand this, let's consider California's geography. To the east of California lies a vast desert, known as the Mojave Desert or the Great Basin. The sun's heat warms the desert air, causing the air pressure to increase. In contrast, the air over the ocean remains cooler, with lower pressure. As we learned in 6th grade, air travels from areas of high pressure to areas of low pressure. The greater the difference in pressure, the faster the air travels. This is exactly what happens here. The high-pressure air from southeast California rushes toward the ocean. These dry and warm winds, known as the Santa Ana winds, absorb all moisture from the regions they pass through. This causes the entire region to dry out during this season, leaving shrubs and trees parched and highly flammable. The Santa Ana winds effectively turn the entire forest into fuel for wildfires. If a fire ignites, accidentally or otherwise, the strong winds spread the flames rapidly, making wildfires uncontrollable in the blink of an eye. Under normal circumstances, wildfires should spread in the same direction as the wind. However, in the case of Los Angeles, the opposite occurred. The fire was first spotted near Pacific Palisades, close to the ocean, but later spread inland. To understand this anomaly, we must consider an interesting phenomenon called the mountain wave rotor. When wind hits a mountain, the side it strikes directly is called the windward side, and the opposite side is called the leeward side. When the wind hits the windward side, it creates a vortex effect on the leeward side. This vortex causes air to spin in a circular motion. As a result, the wind direction above the mountain differs from that below it. In Los Angeles, Pacific Palisades is on the leeward side of a mountain, and the mountain wave rotor created winds moving in the opposite direction below the mountain's peak. This phenomenon played a major role in spreading the fire inland. Once a wildfire grows beyond control, it can give rise to rare and dangerous phenomena, such as fire tornadoes. A fire tornado is an intense vortex of flames that forms during extreme wildfires. It behaves like a tornado but contains only fire. As the heat from the wildfire intensifies, it rapidly pulls hot air upward, while cooler air rushes in to fill the void. This updraft creates a rotational motion, pulling dry vegetation into the fire tornado, further fueling the vortex. Fire tornadoes often overpower the surrounding winds and generate their own wind patterns, making them unpredictable. Wildfires are a reality, and due to climate change, their frequency is expected to increase. Today, artificial intelligence is used to predict wildfire spread patterns, and this information is shared with firefighters. Firefighters then attempt to spray chemicals around the fire to contain it. However, in Los Angeles, by the time one area's fire was contained, winds would spread it to another. The first recorded wildfire in U.S. history occurred in 1871 near Michigan. Known as the Peshtigo Fire, it burned 1.2 million acres and claimed 2,500 lives. From the Peshtigo Fire of 1871 to the current Los Angeles wildfire, nature continues to remind us of the challenges of controlling wildfires. Perhaps, if we learn to work with nature instead of against it, the cycle of wildfires could be broken. Thank you for watching Sick to Succeed video. Don't forget to like and subscribe.